Hi everyone, I hope each one of you are doing fine and staying safe. Welcome to TGIF, another topic, another Friday, another guest. This time we're going to talk about quantum computing. Yes, a very interesting topic, and no better person than Shalaka Verma, who is an SMA in this topic, and she leads a team of cloud solution architects at Microsoft. Shalaka, welcome to TGIF.
Thank you, Sandeep, and thank you for having me on your show.
Perfect. So, quick question, Shalaka. I've been watching a lot of your posts in LinkedIn. I know you've pretty much, gone deep into understanding the quantum area in a significant way. I've been following Gartner trends for that matter, or key trends in the industry for a while now. If you look at any hype cycle, any projections for the next 5 years, quantum is spoken for sure, but not with certain authority in terms of its immediate availability. Right? We know for the fact that yes, there is a cycle time for any technology to mature. What's your take? Where are we on the journey when it comes to an enterprise looking at quantum and saying, you know what, I'm going to utilize that and drive or solve bigger problems? What's your take on that?
Yeah, Sandeep, thank you for the question, and I think you are just spot on when you said, it is still not picking up the steam on the Gartner's and IDG's kind of reviews. And it is really because we still do not have the quantum computers which can take up the mass scale problems and make it really mainstream for across the enterprise workloads. And I would like to provide an analogy with, say, AI. Like, for example, AI really started their journey in 1960s. Then there was a long winter that we saw, and then because of the computational power availability itself, the approaches that were suggested were really compute hungry. Then we landed at 80s, and then again there was a long pause because of the availability of data itself. And now we are seeing a lot of traction and movement and real work happening with AI. Similarly, if you look at quantum information science, I think that journey started pretty way back. It's in 1980s. Even today, most of the evolved algorithms that we are talking about were developed in 1990s. But there was no way to realize those algorithms and try them out on real machines, because to realize a quantum computer, though it existed in theory, to realize it, there were a lot of engineering challenges that had to be overcome, like your cryogenics, availability of your microwaves, off-the-shelf availability of such semiconductors, right? A lot of these technologies, really lasers, had to mature for us to really create a quantum computer. And we are there now. And that is why you see a lot of big techs picking up on the research and development of quantum machines. Having said that, we are still few years early in having the large-scale quantum computers available. But the reason why people need to start looking at it now is for two reasons. One is the quantum is radically different from classical computing. So the cycle to think about the quantum algorithm, develop it, and get this ready on a real machine is going to take a lot of time. So the entry to barrier on a new algorithmic development on quantum is pretty high. And hence, you cannot really coincide that development cycle or your use case innovation cycle with the availability of the machine itself. You probably are going to be pretty late in the game by the time you do that, right? So that's one aspect of looking at why you want to explore business cases and use cases around quantum computing today. And the second aspect is really around cryptography, because we know that Shor's algorithm has already provided a way for us to break the prime factor multiplication problem, right? So now your entire RSA algorithm was based on that. Now think about, I'm just going to take banking industry example and say, you have a cycle of about 10 years to protect your data, which is personally sensitive or financially sensitive payment data. Now, what happens if that data gets hacked today, breached today? It is encrypted by RSA, and hence you are safe. But a machine becoming available 5 years down the line, the same data is going to become a decipherable. But it is, from the industry perspective, it is still going to be a data that needs to be protected, and hence this will call for a breach. Right? So the industries which are working with this kind of regulations need to think through on this, because the cost of that breach 5 years down the line can be humongous, and hence it needs to be acted upon today in a way to protect, nurture that data which is sort of quantum safe. And hence that is another approach why businesses need to be start looking at this technology today.
Perfect. I think in simple terms, you're saying every technology will have a ramp, and it's good to start early because when it reaches maturity, you're actually there to capitalize on those innovations. Wonderful. Thanks for that, Shalaka. Follow-up question to you, Shalaka. Number one, yes, as Microsoft, we announced Quantum Development Kit sometime back, right? And if any practitioner or want to become a practitioner in this space, if they have to get started in the field of quantum computing, where do they start? What tools, platforms, techniques do we have in place today where they can just get going?
Yeah, I mean, first of all, QDK is an amazing platform, Sandeep. I started using it the day I landed in Microsoft, and one of the most easiest way to get started in development of real quantum algorithms. I mean, my first code, I still remember, it was some random number generator. I followed the learning path, a random number generator, but the excitement that you feel that you are really able to create a truly random number, that itself is just so amazing, right? So Q# is a language, QDK is a development toolkit. Both are open source, and you can get started immediately. A little bit of study is required though for the practitioners who want to get their hands dirty. I think at this stage, quantum is not meant for people to just start consuming. So a little bit of understanding of physics, little bit of understanding of the mathematical models that it takes, so that in your head you are very clear on how to formulate a problem on a quantum computer, because it is going to be very different than the way you do it on classical computer. I think that understanding needs to be built. Again, Microsoft has a lot of good learning paths available freely. LinkedIn actually has a good amalgamation of sources from third party as well. And I actually learned a lot from IBM QuizKit, so that is also a good area to start exploring. But there is a lot of material to get started on your own, and then you can download the QDK and start following the hands-on labs. There is a huge amount of algorithmic development that has been given back by Azure Quantum team into Katas. That is a GitHub repository. Again, a very fun way of learning yourself, and really optimizing some stuff there. Very cool, I would say. A reasonable amount of time is required to invest to get started, but fun is there, and I am sure once somebody gets started, it would be very difficult for him to stop on this journey.
Wonderful. I think such a inspiring thought there, Shalaka, because starting early always gives one advantage when actually it becomes mainstream. So thanks for those thoughts. Very inspiring. I know what you shared is super valuable because this is not available in the public domain, and I'm glad I spoke to you today. So thanks for joining TGIF, and again for viewers, thank you so much for joining in. Happy learning, and look for resources in my post where all the stuff Shalaka spoke about. I'll put them there so that you can get started right away. Thanks once again, and happy learning.
Thank you, everyone. And thank you, Sandeep.